Good afternoon, everybody. Thank you all for joining us for this day 3 of the 14th Annual Organics Recycling Summit 2020 and beyond. It's hosted by the Composting Association of Vermont and the Vermont Agency of Natural Resources, Department of Environmental Conservation. I'm Natasha Duarte, the Director of the Composting Association of Vermont. I'd like to take a minute to thank A&R for their continued partnership and especially for their support and flexibility as we navigated the postponement and then new format for VORS. And I'd also like to thank my board for their input and support with the changes caused by the pandemic and in organizing VORS as a webinar series instead of an in-person event. It was a new experience for us here, so I think it's been going pretty well so far with all of the support we've received. I also want to take a moment to thank our sponsors who helped make this webinar series possible. That's Addison County Solid Waste Management District, AgriLab Technologies, Community Bank, Eco Products, Nature Cycle, Rich Earth Institute, Simplicity Engineering Solutions, the Trade Council of the Ministry of Foreign Affairs of Denmark, and Vermont Natural Ag Products. Just a quick promo, there is one more webinar being held tomorrow afternoon, talking more specifically about compost use and stormwater applications. So I would invite you all to come on back and join us for that one as well. Today's program is affordable, buildable, and easy to operate commercial rotating drum composter that is great for schools, organizations, and small communities. Bob Spencer is going to be our facilitator today, and he's going to start us off. Bob Spencer has over 20 years of experience in the development and operation of composting facilities. He's a consultant to communities and companies throughout the country, provides technical assistance to the Massachusetts Department of Environmental Protection, and he assisted the city of Beijing, China in evaluating composting for the 2008 Summer Olympics. Bob is a contributing editor for Biocycle magazine, a certified planner with the American Institute of Certified Planners, is the director of the Wyndham Solid Waste Management District, and president of the CAV Board of Directors. And with that, I'm going to go ahead and turn it over to Bob.
Okay, thank you, Natasha, and welcome to the folks out there in Zoom land. We have a very good turnout for this. Scattered across private industry, state agencies, university people, and compost facilities. So it's great. Thank you, everyone. We are going to hear about a very exciting new composting system out there, but I wanted to set the stage on in-vessel composting. There's a lot of different techniques and hybrids for the technology called in-vessel. And this is just a quick highlight of some of the systems that are operating in the US. There are thousands of in-vessel systems operating around the world. And there's a whole range of options of how they're constructed and operated. So we're gonna hit a few of them. This shows a typical load of commercial food waste, which in the Northeast, and I operate a site here in Brattleboro, Vermont. It looks very much like this. This is another site that I work with in Massachusetts. They take waxy cardboard and soiled cardboard with the food waste. So it's not just barrels of straight vegetative or even meat products. But that's another form of the feedstock. So the type of feedstock and mix of materials is always very important. Excuse me. Okay, and then this is a rotary drum, similar to what you're going to hear more about. It's a larger scale unit. These rotary drums, as we'll hear, have a lot of technological advantages. They mix the materials continuously, typically 24 hours a day, but as John and Katie will say, you don't have to do it that way. They control the moisture, you can collect odor, gases, you make a more consistent product. And in the case of very large rotary drums, you don't have to pre-process, grind, or shred the materials because the material, like those boxes, will break down. And we'll see a system like that shortly. This is another facility in Massachusetts. This drum is now on Nantucket Island, serving a not-for-profit doing food waste. It was at Rocky Hill Farm in Saugus, one of the pioneers of food waste composting in New England with in-vessel technology. What's amazing about this technology is, if you could see the next slide, this is 3 days of retention time in that rotary drum with no pre-processing or shredding. And basically anything that was a food waste material has turned into a very rough but looks like dirt compost product. The other thing you see in there is some plastic bags, etc. Because this was not involved with the shredding technologies, those plastic pieces can now be screened out fairly whole. This is the material coming out of the drum, and the employee underneath the conveyor there is pulling out some pieces of plastic that have made it through. But you can see it's fairly dark and particleized after just 3 days. There's another type of in-vessel system that's gaining widespread acceptance in the US and internationally, engineered compost systems, and I think we may even have one of their reps on the call today. This facility is in West Yellowstone, Montana, serving Yellowstone Park, the building that you see there. And then they also offer aerated covered piles. There's a variety of these fabrics out there that are breathable, and but basically you're adding aeration into the vessels or into the covers through aerated trenches, but the material doesn't get moved. It stays there for usually 3 weeks, getting your vector attraction temperatures and your pathogen destruction temperatures. Then once you remove it, you have to continue to cure it, which we'll see in the next picture. Oh yeah, this is the vessel in West Yellowstone, 4 of them, engineered compost systems. Up close. They each have sealed doors. There's no leachate coming out. Again, these are advantages of in-vessel systems. The material is mechanically augured out of that vessel. It's like a big garage, and then goes into several months of aerated static pile. That's a concrete floor with aeration trenches, and the material is turned some with loaders plus aeration. So it's basically aerated turned windrow following in-vessel composting. You can see some particles of plastic, etc., that will get screened out. Again, back to covered aerated static pile. Engineered compost systems has this. The Gore cover technology has hundreds of installations, maybe more, throughout the world. So it is also considered a less expensive because you're not building a structure, but you have to have a system to deploy and remove the tarps. And that frame you see in the background, I think, is a a winder. Excuse me. Next. Then there's another variation on in-vessel. This is a system that's been running for probably 15 years at the RIKERS Island Correctional Facility in New York City. That's currently operated under contract by Denali We Care. It's totally enclosed, and they also have solar panels on the roof. You can see a tip building on the left. Trucks go in, dump their load. Then that long rectangular building is where the aerated agitated bays are. Then the final building is screening. You can see the wire fence. So this is a technology that originally was adopted for sewage sludge or biosolids, but has been applied to food waste quite successfully in many, many locations. International Process Systems was the original inventor of this, and there are other inventors. This facility does 10 tons per day. You have to amend it with some carbon. They use wood chips. And at RIKERS Island, they have a captive audience, and they grow a lot of their own vegetables and use the material on site. Next. This shows the bay freshly loaded with sawdust topping it. And there is a machine that rides on rails above that. In fact, you can kind of see it to the left. It comes out on a trolley and then gets on the track and works its way down through the pile, agitating, mixing, and moving the material. Next. Here's another aerated bin. It's a stationary system from NATURETECH. They've penetrated the corrections and institutional market pretty good. You can see the aeration pipe system, which actually pushes air through the system and also pulls air out for biofiltration. But this is not agitated. Once it's in the unit, it stays there for probably 2 to 3 weeks. One of the downfalls of some of these is that if you don't have a consistent mix, you can have dry pockets as well as saturated pockets and get uneven airflow. Next. Keep your sense of humus. That's my overview. So I'd like to introduce our next speakers. Sorry to rush through that, but they have the real content here. When I had the opportunity to visit North Country School Camp Treetops in January in the Adirondacks in Lake Placid, New York. And of course I was there to go skiing, but could I pass up a new compost facility? No. So I spent a couple hours looking at the facility, and I was just totally amazed, being in this industry for as long as I have, to see what they were accomplishing with a very low cost system. In-vessel systems are traditionally quite high capital costs, and even the various rotary drums that are out on the market are many times more expensive than this design for the same capacity. And they basically came up with using drainage pipe that you can buy almost anywhere and modify it to make a rotary drum system. Just to highlight the real advantages, you have odor control, you're minimizing leachate generation, you accelerate degradation significantly, and you can have a more consistent product. You can't fool Mother Nature though. You have to get the right mix going in. You can't just be haphazard about it. So with all of these in vessel, you need a good pre-processing or mixing recipe. Okay, John Culpepper is the Director of Facilities. You have his bio there, Natasha. And unless you want to read his background and Katie, since I don't have that.
Sure, we can do that. Or why don't we just turn it over to them and let them do a short, more personal intro to who they are and what they do. And then for anyone who wants to read a sort of a longer bio, that is available on the VORS website, the CAB website on the VORS page. Just
one more thing I want to say. I went back to North Country School in June to see the facility again, and I was so impressed with it. It runs in the winter in cold Adirondack winter weather, and it runs in the summer in much warmer conditions. So it's very forgiving in terms of weather impacts. Take it, John and Katie.
Thank you, Bob. Thank you, Natasha, and thanks for the organizers of this webinar. We're delighted to be here with you. I'm John Culpepper, Director of Facilities and Sustainability, North Country School Camp Treetops. We are a 12-month operation. And with me is...
I'm Katie Culpepper. I'm former farm manager at North Country School and Camp Treetops and co-founder with John of the Compost for Good project. We're going to start just with a little overview. let's see if we can get our slides moving. A little overview of our compost work. As we said and Bob introduced, we have done much of our compost work at North Country School and Camp Treetops. This is a junior boarding school and a summer camp. It is located on a working farm in the heart of the Adirondacks, and you can just almost in that photo see the farmland. Because of the vegetable animal operation that we have here, we have the extensive experience with composting, and we're going to take you through kind of the evolution of our compost systems as we, through the years, over the last 30 years of living and growing up and working here, how we've continued to try to maximize efficiency and effectiveness of our composting systems. And so John's going to take us through a couple of those systems.
Okay, we have been composting, as Katie says, here for a very long time. I've been here for 30 some odd, about 30 years, so has Katie. And we have experimented with a lot of aerobic systems here on our campus. We process somewhere around 35,000 pounds of food waste per year and about 100,000 pounds of animal manures per year. And we've used lots of different styles of systems. Initially, when I first arrived, we were mixing food waste with animal manures in an open windroad system, and it was disgusting. We then, about 10 years ago, no, maybe 20 years ago, we separated those two systems, and we now compost all of our food waste in one facility and all the manures in another. This is an image of the manures in a covered structure. Works quite well. We have, we've experimented with several different styles of straw bale structures. This is an example of one style. About 10 years ago, we constructed a 4-bay static pile area for food waste. In this image, you can see the active bay that would be filled up all the way to the pony wall there, and then 3 other bays would serve as resting bays or storage for the carbon bulking material. 5 years ago, we applied for and received a NYSERDA grant. NYSERDA, for those of you who don't know, is the New York State Energy Research and Development Authority, to design and build an affordable in-vessel composter. This is an image of the vessel that is at North Country School Camp Treetops, and it's been running for about 4.5 years.
So that brings us about to now, and I just want to say that we show examples of the other composting processes because we are here to promote composting, community scale composting in general, but we're really excited about where we now are. And so we're going to focus mostly on the in-vessel design and construction. With the success of that in-vessel about 4.5 years ago when it was built, we recognized the desire to take that success and take it out onto a wider audience. So we very recently, within the last couple months, we created a project called Compost for Good that is aimed at promoting community scale composting, these designs in particular, and we're really excited to share those with you today. So often we get the question of what community scale is, which is a good question. We consider it being somewhere between backyard composting, residential drum composting or static pile, and the larger commercial scale composting. Bob showed a couple really good examples of more commercial scale drum composters or in-vessel designs. We are a little step smaller than that, and we think that small towns, communities, we are having great success with schools, which we'll talk about, but community gardens, hospitals, things like that. A little bit on the smaller scale of what Bob was showing, but somewhere up from the backyard scale. And we will. So how we do this work, so like I said, we started the Compost for Good project a couple months ago, and we organized together with a partner, Jen, who is a local grant writer and compost enthusiast as well. And we connected with a not-for-profit in the Adirondacks called 80K Action, who work on rural community development and sustainability efforts. And so we partnered with them and created the Adirondack Compost for Good that works directly with Adirondack communities, but are also under them in a larger project of getting this out to New York State and beyond. So why we do this work, there are a lot of reasons why we do this work. One of the biggest is that it's silly to throw food waste in the garbage, and we believe that pretty soon we will, as a culture, come to that realization that these are resources that we're having hauled away and treating it like it's trash, which we don't believe it is. The other reason is that more and more states are going to begin requiring composting. You're seeing that in Vermont. New York State is not too far behind. So we think a design like this can help communities, towns, municipalities deal with that upcoming pressure from state legislation. And we believe that this in-vessel design could be a solution among many others to help address the hopefully increasing need of compost facilities. And then on a larger scale, we believe that community scale composting in general builds local resilience, soil fertility, and helps to reduce greenhouse gas emissions, which John will go into more depth.
So composting can lower greenhouse gas issues on both the source and the sink side. When food waste is buried in landfills, it produces methane, which is a potent greenhouse gas. And there is more and more evidence that when compost is applied to land, that land treated properly can actually pull CO2 out of the atmosphere, creating a sink for that carbon. Compost economics. When you consider on-site systems like what we have or like what others are developing, on-site systems can reduce costs that are inherent in those facilities, such as tipping fees. I in fact, often talk with people, and when I ask them what their tipping fees are or what their overall cost of dealing with their food waste is, they often don't have any idea. And of course, that cost varies all over the place, but it can be a significant cost. So by composting on site, you can supplant or reduce those costs and create a value-added product. In fact, 7 miles from where Katie and I are sitting, compost is being sold at a little garden center at $9 a cubic foot. That may shock you in Vermont, but I have seen those prices not only here in the Adirondacks, but in Massachusetts as well. Can eliminate the purchase of fertilizers for many facilities. That's a cost savings. I want to get into the design particulars of what we created. When we applied for and received the grant, I really wanted to have a unit that was simple. We went through many iterations, and I kept going back to my partners, and I kept saying, it's too complicated, we got to simplify it. So really wanted off-the-shelf materials that were available anywhere in the world. The only component on ours is that gives us a little bit of trouble are the steel bands that sit on the drive wheels. We ended up having to have a steel shop about an hour north of us bend those. We then took those pieces of steel and welded them around the drum. And I'm convinced that we can find ways around that as well, so that a shop can deal with that also. I wanted a composter, an in-vessel unit that could fit within a 40-foot shipping container. I wanted the drum that just sat on drive wheels instead of a complex chain or other drive system. I wanted it super simple. And a unit that was capable of processing all sorts of unsorted waste. Our design can be built by those with moderate shop skills in a moderately well-equipped shop. We intentionally did not automate ours, but certainly this could be. We did that because we wanted our students and our campers to be involved in every aspect of the process. Ours can process 200 pounds a day or more and up to, we believe, about $15,000 a year. Sorry, 50,000 pounds a year. Most importantly, this is, we wanted a design that was inexpensive. So we built ours with $15,000 in material cost, and I know that we can get that cost down. I get into the particulars a little bit. This is inside the drum. So this is a 4-foot diameter, 20-foot long, double-walled highway culvert. And on the inside, we've welded 3-inch by 3-inch angle iron, 6 of them, running the full length of the composter. And on the ends are tabs that are welded, and that are the attachment, those are the attachment points for the 2 ends of the drum. So on one end is a marine plywood loading door. On the other end is a steel plate with a hole in it. We believe we can reduce that down to a marine plywood as well. These 3x3 angle iron pieces also provide the rigidity necessary because when you heat up a culvert like this to 140, 150 degrees, you need something to stabilize it, so that those angle iron pieces do that. Have we created a perfect in-vessel composter? Of course not. As Bob mentioned, there are many other units that can process much faster and much more material. But we designed this to be modified. This unit can be, thank you. This is an open source design, and our goal is to get the design in many people's hands. Modifications could include using different materials, a different style of drum, perhaps a dam pin stock made of fiberglass that would eliminate the need for the steel bands altogether, perhaps. The drum could be larger. Ours is 4 foot in diameter. A 5 foot in diameter drum would take volumetrically over 1.5 times the volume of our 4 foot drum. And I have no doubt that we could easily modify this design to accommodate that. So here's a couple of examples of modifications that we have made. On the left of the screen is the original that is still in existence at North Country School Camp Treetops. And on the right, we've made, I think, 4 of these already. And when I say we, that's not me and Katie, that's the contractors who we work with. And so you can see a lot of modifications that are made, like the steel pieces that held the keeper wheels that prevented the drum from walking downhill. This drum is, of course, on an angle. And so you need some mechanism to prevent that drum from walking. Turns out that all the steel is not needed, just a smaller keeper wheel is fine. Other modifications we've made on here, reducing the length of the discharge chute and other things as well. We're getting more of these composters out in the world. Thanks to a second NYSERDA grant, we were able to build and gift 3 more of these units. All 3 of these are in 40-foot shipping containers. And also an independent school, Pingree School in New Jersey. Their maintenance department used our plans and built their own, and they've got a functioning composter as we speak. There are 5 total out in the world, 4 associated with schools and 1 at a natural history museum. And that natural history museum is about 40 miles from us in Tupper Lake, New York, called the Wild Center. And this is the facilities manager, Dave, who's a proud, very proud operator of this little unit. He's inside of his shipping container. This is one at the Hermon DeKalb Central School. This is a public school close to the Canadian border. And we're going to show you a video of the one in Lake Placid. Lake Placid High School partnered with the Shipman Youth Center, which is right next door to them. Whoops. And this is a video of theirs in action. So I'll stop it there just to show that the discharge material is emptying into a cart, a wheeled cart that students take out, dump into an area for secondary decomposition. Dave at the Wild Center has a big, a much larger container that he takes out with a bobcat. You see there's a fair bit of room in the shipping container to get around. Lake Placid High School has done something really interesting in my mind. Their goal was to have students learn business practices by selling compost and actually getting paid. So that's an exciting addition to Lake Placid.
So we're going to get into the North Country School and Camp Treetops compost operation, since that's the one that we have the most experience with. So we'll take you through kind of the steps that we go through for collecting and processing food waste. Food waste is collected in the dining rooms and into 8-gallon buckets. That's from the kitchens and the dining rooms. We do pre and post consumer waste. It's taken down by campers and students, depending on the time of year, and brought down to our compost facility. Here you can see inside the compost facility, they have dumped the food scraps and they're now chopping it into small pieces to get the diameter size down to increase the surface area, to decrease the amount of time it will take to break down. It then gets mixed with a carbon material. In this case, you can see that we're using wood chips. Any carbon material is fine. I think Bob said this earlier, just depends on, your recipe will change a little bit depending on what kind of carbon source you use. We were using wood chips for a long time. That's a really good option because they are readily available, often free. They're a little bit bigger diameter than other things that we use, so they can take a little bit longer to break down. We've also played around with shavings, and we are now currently using exclusively wood pellets. In the picture on the left, that is a auger-fed silo that holds our wood pellets. We have a couple wood boilers that we use to burn wood pellets, so we have those readily available. It's not the cheapest option, but it's something that we have access to, and it makes for a really nice finished product. After the food waste is mixed with the carbon material, it then gets loaded back into the 8-gallon buckets, and you can see here a student bringing it up the stairs to the loading door. We'll go into the drum where it then gets rotated.
All right, another video. This is Katie operating the composter at North Country School Camp Treetops. You'll see, I'll pause here, there are some pinch points here that can be quite dangerous. In the previous slide, this is an older image. In the previous slide, you saw a big fence around this. Important to prevent people from getting into those pinch points. And ours screens the finer stuff, and the bigger stuff then dumps into a garden cart. The switch is in a locked box and is a momentary switch. So in order to operate this, you have to have a key, only adults operate it, and you have to hold the switch down as you're rotating. Talk a little bit about drum rotation and retention time. This unit is built such that the drum should stay half full all of the time. The number of rotations or the frequency of rotations very much depends on how much is being loaded into the drum. And the material travel speed depends on several factors listed here. We're in an odd time like many of you are, and given that our campus isn't fully active at the moment, we are loading our drum about once a week, or now about twice a week. But typically in normal operations, we load every day.
So this is the output end of the drum. This is a stable material. This retention time, I think, as John said, is about 20 to 30 days, not quite the 3 days that Bob talked about, but still a pretty quick retention time. So you can see that it's not a totally broken down product. It still is perfectly able to be used. When I was farmer here, we would use this extensively on our gardens, especially on areas where we were experimenting with no-till, where we weren't interested in incorporating the material anyway. We use this as a top dress, just layering it onto the beds, and that helped to bring nutrients into the soil to kind of kickstart soil life, to retain moisture, and to suppress weeds. And it was a really, really nice product. If you want a more sifted product, you certainly can do that. We've done that. We have done that with by hand with a screen that we've just used by hand. We've had a bike-powered trommel, and we now have a motorized trommel when we want to get the larger diameter material out. And we have a video of that sifting in process. So you can see the larger diameter is coming out the end facing us. That's a paper plate that didn't quite break down. And then on the side there is the finer material. The larger diameter material can come out, can be chopped up. Again, those are things like bones. Sometimes if apples or oranges aren't chopped up to begin with, and they kind of form a mass and don't break down very well. So there's some breaking down, some chopping that happens, and then it can be loaded into the front of the drum again. And the finer material can then go in for secondary decomposition.
So secondary decomposition is often considered the cooler phase of breakdown. It's where large carbon molecules are broken down into small organic acids. These acids, humic acids, fulvic acids, those sorts of things, persist in soils for sometimes for decades, and aids in water retention, nutrient retention, friability of the soil, and gives the soil other positive characteristics as well. Here you see a finishing pile inside, right next to the composter at North Country School Camp Treetops. We finished inside, we finished outside, but finishing is an important part. This is a lot of uses for compost. These are some images, again, of our campus. But an area that a lot of people don't think of is forestry. I think if we had more and more compost, and certainly forest areas would benefit as well. Our organization, Compost for Good, what can we provide? Free and available to anyone who is interested. We can provide you a design document, 20-page operating manual, fit-up document for shipping containers, support for DIYers who want to build their own. And by the way, we do have a contractor just down the road who can build and deliver these to anyone, anywhere in the Northeast, and more than happy to share that contact information to anyone who might be interested. We also have social media outlets, I should say outlet. We have a Facebook page right now with about 125 people and growing, and these are folks who are interested and want to learn from each other. Hopefully we'll be on other social media outlets before too long. We also offer consultation for communities, individuals, organizations who want to know if this might be if our design might be a good match for them, and even if not, how they might be able to engage in some sort of on-site processing, composting. So here's the front page of our design guide. If you open the design guide up, you see each component part is identified, and then it gives you part numbers and where you can obtain those parts. The operating manual, it's a 20-page operating manual, and I'll just throw in here a plug for James McSweeney's relatively new book. I think it came out about a year ago, called Community Scale Composting, I think, if you haven't seen it. At least for me, it is probably the best book out there on community scale composting. Our 20-page operating manual is like a vastly condensed James McSweeney book, but gives you everything you need to know about how to operate this. Open source design that we've created allows for constant improvement, ways to lower costs. We hope to have people take this unit and modify it. There's no question in my mind that it could be powered by solar panels or even hand powered, and allows for the development of a community where things are shared. For those who might be interested in building their own or purchasing their own, there are funding sources. Again, operating costs. It is important to realize that you can offset costs and create a value-added product. So return on the investment depends on the investment, of course, and depends on the offsets. But the little bit of modeling that we've done in this area indicates that the return on a $15,000 investment, if the labor was yours, is pretty fast. There are also local, state, and federal sources. USDA is a good source. State environmental agencies, state energy agencies, for example, NYSERDA, where we've received 2 grants. I've received a number of grants from NYSERDA, but for the composting, we've received 2. Also foundations, local businesses, and crowdsourcing. I want to key in on local businesses. A lot of times, local businesses can get pretty excited about something that you're doing. If they're a vendor or if they're a partner of yours, it's amazing sometimes how just asking a local hardware store or whatever will yield interest and sometimes money. Get into a little bit of food waste collection systems. As you might imagine, there are hundreds of different models out there. We wanted to highlight one that's close to us, which is Blue Line Compost, and we do this only because they've developed a model that I think is replicable and is really interesting. We've experimented with a lot of compostable products. We've tried, well, you name it, we've tried it, from t-shirts to tennis shoes to whatever. For us in this unit, usually these items have to go through secondary decomposition. We don't have the ability, but chipping or shredding would greatly help. And a plug for the Biodegradable Products Institute, BPI. They do a lot of great work testing the products out on the market for compostability. And so if you're not aware of them, I encourage you to become aware of them. Lastly, wanted to share with you some work that we have done over the last 8 months or so with using human urine as a feedstock. We've developed a recipe using only human urine, water, and pellets that in a static pile allows that pile to heat up to over 131 degrees for a week or more, which meets part of the EPA's guidelines for Class A biosolids compost. We've processed over 2 tons of urine. And what we have learned, we've learned a lot of things, but one of the things we've learned is that when added to food waste, the temperatures go up and seems to accelerate decomposition, creates a more uniform product in the end.
And that added to the food waste was in the in-vessel drum, whereas most of the extermination has happened in static piles.
Exactly. Thank you, Kate. I happen to believe that composting human urine has the potential to solve some of our environmental issues associated with wastewater treatment systems. High temperature environments tend to break down pharmaceuticals and other complex compounds. And I think there is enormous potential here. So I'll show you 2 finished compost. On the left is our food waste compost. You can still see a little bit of eggshells in there. And on the right is our human urine compost. That's just the recipe, human urine, pellets, and water. If you grab a big double handful of both, they both smell like a healthy forest floor. We've got Penn State nutrient analysis, other analyses on both of these finished compost. I'd be more than happy to share those with anyone interested. And contact information. If there are questions that we can answer after this, that's great. If there are questions that you have that you'd like to ask one-on-one, please feel free to reach out to me or to visit our website. So I think at this point, I will stop sharing and turn it back over to Natasha.
Great, thank you guys so much. Do you want me to go ahead and read some of the questions out for you, or Katie, were you gonna?
Sure.
Okay, great. So one of the questions was, with the volume of material that you add each day, how frequently do you need to turn the drum?
Turning frequency depends on how much is added. So it's a little counterintuitive, but the drum, we want to keep the drum half full all the time. So, and that's counterintuitive because as the drum rotates, the material inside, it's moving downhill because that drum is on an angle, and it's moving downhill depending upon how much free space that material falls through. So if a small amount of material is added, then one rotation is probably enough. If a large amount of material is added, then probably more rotations are needed unless you're below half full. So you want to keep it half full to keep the thermal mass there, but you don't want it to go over half full because as rotation happens, you have less free space for that tumbling material to fall through, and therefore less travel distance. So it really just depends, and we rotate it depending upon what our eye says needs to happen. If it's half full and we add 75 pounds, then probably a rotation or 2. But the drum can easily be angled. The angle of the drum can be increased or decreased to change the number of rotations needed to move that material through.
Sure. Sounds like this is where the art part of the art and science of composting comes in.
There you go.
Right.
You learn as you operate. I think you addressed this, but I'll just go ahead and ask, and we can reiterate. Perhaps it's about composting old T-shirts, and if you shred them by hand or use a piece of equipment. I think you said that you didn't have the capacity to necessarily shred, but that would certainly increase the speed at which it breaks down. Was that right?
Correct. Yes. And so I've thrown a couple of my old cotton T-shirts in there, and they come out pretty decomposed. Run them through twice, and they're gone.
Nice. And I imagine part of that will depend on, cotton shirts versus canvas sneakers might take longer then.
Exactly.
Right. Exactly. We had one question in terms of the urine added to compost and concern about testing for pharmaceuticals or other things. So I think that's really where the hitting those temperature requirements becomes key. Do you want to elaborate on that at all?
Right. We are confident in the ability to hit over 131 degrees for more than 3 consecutive days. So we're not worried about pathogens. And in our setup, we're not set up to test pre and post. So I haven't yet checked for pharmaceuticals. If I do, it would be interesting, but I'm not sure how valuable it would be, because we don't know how much, what the pharmaceutical loading is on the front end. So having data on the back end would be, again, interesting, but every report I have read indicates that many, if not most of those pharmaceuticals are denatured, broken down in the high temperature environment.
Yeah. And Natasha, this is Bob. Can you hear me?
Yes.
We have a couple folks from Rich Earth Institute, the urine recycling, on the call, and I thought maybe Abe or someone would like to weigh in on that, because they have done research on pharmaceuticals. In fact, we are working with Rich Earth and John and Katie on looking at combining urine with our food waste composting here in Brattleboro, Vermont. Hi, Abe.
Hey, Bob. You spotted me.
Yeah, just down the hall, right?
I thought I was just a spectator today. Hi, guys. Yeah, so the question of pharmaceuticals, we're in the middle of a multi-year study right now with the University of Michigan, looking at pharmaceuticals in urine, measuring the amount that's present in the urine to start with, and then looking at what happens when we use that as a fertilizer in an agricultural setting. So what we have found so far is that we've collected urine from thousands of people at public events, at festivals, at rest stops, things like that, and have quantified the levels of pharmaceuticals in that urine. And then we've grown lettuce and carrots in the field using that urine without pharmaceutical removal steps. We've also experimented with ways to remove pharmaceuticals, but I think the relevant thing is without removing pharmaceuticals, what we found was that the drug that came through the most strongly was caffeine, no big surprise. And then we also saw things like ibuprofen, naproxen, which is in another over-the-counter pain medicine, or other common ones. We could measure them, but to get one tablet worth of that, you'd have to eat a pound of lettuce from this field every day for about 1,000 years. So it's a tiny amount, and at those levels, it seems like it's likely not of concern in terms of human health, also not of concern in terms of environmental health, because the levels in the soil, levels in the water under the soil of that study plot were also on par with a lot of surface waters in the country, just rivers as they exist in the modern age. So that's how our research gets in there. And then with composting, of course, we would expect to see many of those pharmaceuticals vastly reduced or eliminated. So I'm kind of backing into this answer by saying, even if you don't do any treatment to the urine, it doesn't look like it causes really that much of a concern. And if you composted it, I would think you'd have much lower level.
Yep, and I'll just jump in. Thank you for that, Abe. And also a plug for the You're in Your Garden webinar series that I circulated. So you can find that on Richards Institute's website or Facebook page, or the CAV Facebook page as well. I just want to give a call out to our Tuesday webinar in the VORS series that was looking at emerging pathogens or issues of concern around compost quality. And pharmaceuticals was touched on a little bit. It wasn't the main focus, but there is some information that was presented there. And so you all who are interested in, if you weren't able to participate in that, it will be posted on the CAV website in the coming weeks. So I encourage you to check that out for some more information on things like pharmaceuticals, or some other contaminations that might be of concern. But I'll just agree and underline that composting, not just the heat, but also the microbial action during the composting process, is really quite effective in breaking down a lot of the different compounds that we might be concerned about. So there are some other questions that have come in that I do want to make sure that we have time to get to. So I'm going to jump away from the urine for a moment. Ask, is the building that the drum is in heated, and do others that use the drum in a shipping container heat the container? In terms of how important is that, especially in New York and Vermont and in the northern climes where it can get quite cold?
Yeah, it's a great question. Ours at North Country School Camp Treetops is in a building that is lightly insulated, and it's fairly large. It's probably volumetrically many times the volume of the drum itself. And I do have a little space heater in there that runs. But we're at 2,200 feet in the Adirondacks. We hit, on a fairly regular basis, we'll hit 30 below here. And we've not seen problems with our composter over the course of the 3, 4, or 5 winters that we've operated it. We have additional information from those in shipping containers. We have at least 1 year's worth of data coming from our operators, those of us the partners of ours who are operating in shipping containers. In our fit up instructions, we made sure that each had the ability to install a space heater. In some cases, the folks have found that they run those space heaters lightly, other cases, not at all. The composter in New Jersey is in an unheated building, much milder winter temperatures. So long answer is we lightly heat ours, but we don't think that it's absolutely necessary. In fact, there have been winters where we haven't run any heat at all, and we will still reach temperatures of they vary, but up to 140 degrees or higher during the wintertime. We check our temperatures with the standard compost thermometers that we stick just inside the loading door, but we also run data loggers through. We tie data loggers, we have 2 of them. We tie them to wiffle balls so that we can find them when they come out. And they temperature data log every 5 minutes. So we've got reams and reams of data on the temperature inside of our drums as the data loggers move through the drum with the rest of the material.
And this might be obvious, and I think John mentioned it before, but in keeping up temperatures, it's important to keep the drum half full. That just in any compost pile, if you have less material, it doesn't have the thermal mass to keep the temperatures up. So through the winter, if you're maintaining that half full, that's enough material in there to maintain those high temperatures. But if you were to drop down, if you didn't have food to add, then you'd be looking at having a harder time keeping temperatures as high as we are.
And just a side note, with all the data that we have, we also have all the raw data. We're taking temperature data in these loggers every 5 minutes. And we can plot those out on a graph, but very, very interesting. We see temperature drops, in fact, crashes right after rotation. So For those of you who are interested and really want to geek out, I'd love to have a conversation with you, but there is strong evidence that disrupting the environment inside the drum causes a temperature drop. The extent to which depends on lots of other factors, but fascinating to me anyway to try to understand this.
Do you have a sense of how long it takes for the temperatures to then go back up?
They're all over the map. Sometimes it takes 3 or 4 days to go back up, and sometimes the temperature drops can be from 145 degrees down to 90 degrees in a matter of, well, in some cases in a matter of just an hour or two.
Wow.
It's fascinating.
That is very interesting. And I would, just to add on to that, I would imagine that in all of these cases, whether it's in a building or a container, shipment container, that there is some protection from the wind. So, you know, again, it's not like it's outside being iced over or snow piled on or extreme wind, cold winds. And I think
that's right.
Yeah, that's part of it.
These are not designed to be operated out in the open. If it were in a temperate environment, just a covered shed would be fine, but yes, these need protection from the wind.
Yeah, great. We did actually, just looking through the questions here, had one more. We're going to go back to the urine waste study, and the question is, why were you looking at the urine composted without the food waste and then with the food waste? And so, like, what was the information you were trying to get of just the urine wood chips?
Yeah, great question. And by the way, they're mixed with wood pellets, not wood chips. We don't have any. We haven't experimented at all with wood chips. Mm-hmm. So what I really was keen to find is, could one simply use just those 3 ingredients, human urine, water, and pellets, to obtain temperatures up above 131 degrees. So I wanted to eliminate all the other variables. And so we've demonstrated that definitively. And once that recipe, and we've moved now, can't tell you how many, well, over 4,000 pounds we've run through the composter. But it's hard to know what's going on in there because you can't separate out the decomposition from the food waste from the urine. So, but to me, just to know that urine by itself could be composted, turned into a fertilizer, a soil amendment, is just fascinating to me.
Mm-hmm. I think I'll piggyback on that and say that one of the biggest, I think, reasons, one, we wanted to know, there was interest in knowing what it would look like to just compost that, but also this is happening at a school where that compost is used on fields where we're growing vegetables for a community. And so with a lot of unknowns, like we were talking about before, about pharmaceuticals, about pathogens, we have answers to some of those questions, but there's still a lot unknown, and there's still some PR hurdles to get over before we want to be composting human urine with our food waste to be used on our vegetable gardens. So that was one of the main reasons, I think, why they started out as separate entities. Unfortunately, with COVID, we didn't have a community here on campus, and so the drum compost, the in-vessel composter, was kind of open and available to take on some more bulk material. And so that's why we were then able to begin to use it to experiment more with this. But the biggest thing is that we wanted our food compost to continue to go through and to be able to be used easily and without too many questions on our vegetable gardens.
Good point, Katie. Thank you.
That makes a lot of sense. Thank you. I think we've gotten through the questions that were in chat. Does anyone else have other questions? I would just, while people are maybe typing in, I would just say that I'm quite interested in your use of pellets. I promote and use for both backyard and micro scale, really, in at least James McSweeney's parlance, in terms of community composting. So much smaller scale community compost sites are using an insulated tumbler, and their instructions promoted using pellets as the best source of carbon. And we've actually consistently had a hard time getting temperatures up, and are much more successful using wood shavings, which are much more affordable than pellets. And so it was interesting just to hear you talking about some of those different sources. And maybe it's a volume thing, because I really don't know anyone who has had good success. And I'm talking, like anywhere from like a household of 4 to maybe an apartment building of 4 or 5 units. So it's much smaller volume. But we've struggled with the pellets.
But it could also be an aeration thing or a moisture thing. The larger wood chips allow for greater aeration. And let me just say that wood pellets is not what I would recommend right off the bat. That's the most expensive way to go. But we started using them because I wanted to know how they worked in the event that someone wanted to automate the process, auger the pellets into the system and so forth. And so pellets do break down very quickly into sawdust. That's a pretty compact, dense material. And if you don't have a way to aerate efficiently and frequently, then you can run into problems. Bob, you had your hand up, I think.
Yeah, I just wanted to comment on another variable, and that's the amount of time of rotation of the drum. Most of my rotary drum experience is these are 24/7 rotations. Some of them have variable speed drives, so you can even vary that speed of rotation. But I know this would happen if you were to run your drum on a continual, and I think you can get it to rotate, 4 times an hour right now?
It's one rotation every 60 seconds.
Oh, so you'd get 12 an hour? Or how many?
Well, we could get up to 60 an hour if, then you held that momentary switch down the entire hour.
Okay. But if you were to run it at that, you would have high temperatures all the time. You wouldn't see the up and down cycle, because when you turn it off, you basically go anaerobic. And the beauty of rotary drums, and you do it in your system, is it's constant exposure of surface area, constant, 24 hours a day, and new food source to the microbes. Microbes can't move. That's the thing. That's why the rotary drums bring the material to the microbes. So the variable there of rotation and speed of rotation is a big factor. There's also drum systems that have air injected, and basically most of them, it's counter to the flow of the waste. So the discharge end has a blower, positive displacement blower, pushing air, even very low volumes, and that brings hot, moist air to the fresh material. And that's another variable that I've seen work, where you can jumpstart your material in the winter. But that's why those 3-day retention times, they literally work. But it's more expensive. You've got electricity, you've got higher gear ratios, higher, powered motors. So it's always a trade-off.
Yeah, and I think the diversity of systems and how to run them is part of what makes them accessible and for so many different types of sites and sizes, right? Because you can really meet whatever the needs are of a community group or an institution.
Exactly.
By those modifications that you talked about, John and Katie, and by the differences. So, we have another question that came in. It's a little bit of an aside, but I'll go ahead and read it. One of the participants is saying that they used aged horse manure with bedding for carbon, and should they be worried about pharmaceuticals used with horses? The manure is aged 2 to 3 months. Do any of you want to weigh in on that?
I'm no expert. I'm happy to, but that never stopped me before. Abe may want to weigh in. My gut tells me that very much depends on the horse manure you use. In Lake Placid, we have horse shows and beautiful tons and tons of horse manure that could be collected down there. We chose not to do it because they medicate frequently. These are show horses, and they throw their needles right into the waste. So we couldn't we couldn't tolerate that. We couldn't have one single needle in our in what we were hoping to bring to campus. So a regular farm horse, you know, not a high show horse. My guess is much fewer medications, and so less of an issue. But and once that material ages for 3 months, I'm guessing that some of that material goes away, and then once it goes into a high temperature compost environment, more of those pharmaceuticals are broken down. So that's my 2 cents.
Bob, do you want to chime in at all, or?
Well, as we in Vermont know, horse manure led to a contamination with persistent herbicides. So horse manure, because of the herbicides used on the hay fields, has found to persist in the guts of the horses and survive into the manure and contaminate compost at levels that is phytotoxic. So that's been an issue in some facilities. At my facility in Brattleboro, we don't take horse manure, but it's a concern, and that's even just gentleman horse farms.
Yeah, so and that's again the persistent herbicides that are used for growing the feed for that then horses eat, and so it's a slightly different angle that is touched on a little bit in was touched on a little bit in this past Tuesday's webinar on compost quality and some concerns. So check that out if you weren't there for that. And there are remediation techniques that you can use, but the composters that I know who accept horse manure or who are composting their own horse manure, but then they obviously have more control over it. If you're bringing horse manure in, I would just recommend that you have a good relationship with the horse owners where you're getting it, and that you have those conversations and understand what they're being fed, how is it being sourced, what is the level of medication. These are all great questions to be asking. It doesn't mean don't ever take horse manure, but just educate yourself about it. And there's a lot more information on these topics that you can find online, or reach out to me and I can help make some of those connections. Any other questions from the let's see, given that, for example, Sunrise Farm, do non-organic table scraps pesticides persist? Ariel, I'm not sure exactly that I understand your question. So are you asking if, we're getting a little afield here maybe from the topic of today. So maybe you and I can pick that up afterwards and we can have a little bit more dialogue around that. One of the, although I do understand that it's easy to go down some of these rabbit holes. One of the things that I would just really like to express and say that I noted in the presentation that John and Katie gave is just the emphasis on community composting and education and outreach. And I think that goes so far. So thank you for your work in terms of normalizing responsible management of food scraps and composting. And I think the more that it shows up in, you know, the wilderness centers and schools, and kids are engaged in the full process and see the whole thing happening, that just goes so far in terms of support. I mean, that positive experiences like that support composting at all levels. So not only the backyard and the community level, but all the way up to the commercial level. And so I think that's such an important piece. And I also just wanted to note some of we just this morning had a session on residential organics food scrap haulers. And one of the things that came up there was just sort of this need of not, you know, you may know what you're doing from the organic sort of technical side, but there's all this business stuff that has to be figured out as well if you're starting your own business, and sometimes that's minimized. And so I loved the example that you gave about Lake Placid in terms of really focusing, sort of marrying the two and focusing it as a business opportunity for youth. So not just educating about the compost, but also everything that goes with actually making this industry thrive and survive.
Yeah, and one of the things that we're really excited about in this work, we're not selling, we're not doing a lot of the real work, but what we're hoping is that we begin to connect people. So Blue Line Compost, who their website was up, John explained them a little bit. They're in the area. We have a close partnership with them where they're really willing to give us information about the business end of things. That's not our, as you said, that's not our, where we're really interested, but what we are interested in is the data and the information of how do you do this? How do you do this as a business? And is it economical? Is it only economical if you have a 5-foot diameter drum? Is it only economical if you know, all of those things? And so part of this resource base that we're trying to build are those toolkits of, okay, so you want to start a business. Here's what we know. Here's who we can connect you with. Here are the resources that we can provide you, or the connections that we can provide you. Same goes with, so you want to start an educational one. What are the resources that are needed for that? So while we're looking at kind of local communities, we're also looking at expanding this network, this community of people who are composting in all those different ways, so that someone coming in can say, I don't know, I know business, but I don't know composting. And so how do we connect them to the right people? Or I know composting, but I don't know business. So that's something, we don't have it all there. We don't have the toolkits and the resources all together, but that's part of what's really exciting us about this work, is to continue to build that resource base to be able to share. Bob, did you have something to add?
This is on a totally separate issue, is where can people see one of these units? And John told me that the Wild Center is a public environmental education center, although they're just shut down now, will be providing and integrating that into their interpretive programs.
Yes, and we are in close partnership with all of the 5 drums that are in operation right now, the 4 in New York and the 1 in New Jersey, and all have, you know, things are a little bit different right now, but all have agreed to be a host site, are willing to share with you the ways in which they are incorporating it into their communities or programs. So certainly we can say from the North Country School Camp Treetops side, we'd love to host anyone who's interested in touring, but also if one of those other sites is closer to you, we can help make that connection to be able to see one in action. And all are, as far as we know, in operation right now, even despite the current difficulties. So.
Yes.
Great. Well, seeing no other questions, I'm just going to thank our presenters, Katie and John and Bob as well, for framing up this conversation. And remind everybody that there is one more webinar in the VORS, virtual VORS series, which is tomorrow afternoon, looking at compost use in stormwaters and specifications, a little more technical maybe, but it should be a great session. So please join us there if you can. And also just a quick reminder that at the end of the week, you will all be getting a link to a survey. If you could just, it's short, I promise, just take a couple minutes to fill it out and give us your feedback. And this year, especially, we're looking for feedback on the format, because we had to make this up and do it virtually, which is a bit different for us, as well as the content. So it would be great if you all could take a minute. And with that, I will just thank everybody, and I hope to see you tomorrow.
Thank you all.